So what I'm going to do is I'm going to show you how to find the focus and the directrix for a parabola. Now, when applying the focus and the directrix, we need to introduce a new equations, because these two are great for solving a quadratic equation. They're great for graphing a quadratic equation, but they don't really help us so much in determining what the focus and the directrix are. So I'm going to introduce a new equation. It's still going to have x and y's, but I'm going to add an extra variable. So these represent quadratic equations or parabolas that will open up or open down, and this one as well, but it just comes in a little bit different format. So this one is x minus h squared equals 4p y minus k. All right, so in this case, when looking at this problem, what we're going to be doing is we notice that we have a little extra value in p, and that p is going to be what's going to help us determine our focus and our directrix. So if I was going to go and take a look at two quadratic equation or parabolas, we know that these quadratic equations, when vertical, are either going to open up or they're going to open down. All right, and we know that the next important thing is this is what we call our vertex. And we knew that from our vertex form where we have hk. So we can just write up here that we're going to have the vertex is going to be h comma k. So you can see there's my nice little vertex, and that's going to be the lowest or the highest point of my parabola. So what does then this little p represent? Well, what p is going to represent is the distance from my vertex to what we call the focus. And it's also going to be that exact same distance from my vertex to my directrix. So this little dot inside the parabola is my focus, and that's what's going to be what, kind of your parabola kind of, focuses in on. If you were to kind of draw lines, they're all going to reflect into your focus. Now, when looking at our directrix, this is going to have the exact same distance from our vertex to our focus as from the vertex to our directrix. And we'll see what we're at. So this value is p as this value is p. So the distance from your vertex to your focus, again, is p. The distance to your directrix to your focus is also p. Now notice that my directrix is a line and my focus is a point. So that's going to be very important when we're actually going to be determining these. So let's first determine what the general rule is, how to find the focus. All right, so if I'm given an equation that's in this format, or I'm just given a set of information, I need to be able to say, all right, so I know the value for my vertex to my focus is always p. But notice how it's always vertical, right? It's either I'm going down to find my focus or I'm going up. But they all lie on my axis of symmetry. So it's very important to understand that the vertex and the focus all lie on the axis of symmetry. Okay, so now that what I notice is here is when a would be positive, and here's when a would be negative, all right? So to find my focus, what I'm going to do is I'm going to take whatever my vertex is, and notice the k is going to be my y coordinate. And if I go up, that's going to give me my focus, or if I go down, that'll give me my focus. So to find the focus, the h is not going to change. I'm not going left or right to find the focus. However, I am going up or down. So we're going to say k plus p. Well, you could say, well, yeah, you're adding p going up here, but you're going down here, so should it be negative? Well, no, because in this case, my a is negative, so therefore, what that means is my p would actually be a negative value. So you can still add a negative, which means it would be going down. Now, when trying to find the directrix, all right, notice that the directrix is not a point, it is a horizontal line. And we can write horizontal lines as y equals, all right? Now, notice if I go up to find my focus, I need to go down to find my directrix. So therefore, it's going to be y equals k minus p. Again, we're not going left or right, so our h is not going to be affected. And then again, you could say, well, here my directrix is up, so but remember my p would be negative, so it would be k minus the negative p, double negative, which means we would go up. So therefore, for a vertical parabola, that is how you find the vertex, focus, and directrix. Thanks.